All right, so 323, multiplying polynomials and the distributive property. Here is where we make our biggest jump away from the algebra tiles and into the algebra. I'm still going to reference them a little bit, but the goal today is to really focus on the algebra and not the algebra tiles. So use the dimensions, length and width, of the area model at right to write the area as a product of the dimensions equal to the area as a sum. So we want to look at the side lengths. So we've got x minus 4. And then we want to look at the length across the top, which is negative x plus y plus 2. And instead of going through and finding the area of these 6 rectangles in the picture, we're going to find those 6 by using our binomial, x minus 4, 2 terms, multiplied by our trinomial, negative x plus y plus 2, which is 3 terms. Now, how do we do that? We use the distributive property. We distribute the x minus 4 multiplied by each of the parts inside. We talked about this in the last section, and we're going to show you today how to make it a little bit more efficient. So what's really happening is we're multiplying negative x by x minus 4, and we're multiplying y by x minus 4, and we're multiplying 2 by x minus 4. And that's going to yield 6 terms. Now, the picture would have given us 6 terms, but this is also going to give us 6 terms. So negative x times x would be negative x squared. Negative x times negative 4 would be plus 4x. Y times x would be plus yx. Y times a minus 4, minus 4y. Plus 2 times x for plus 2x, and plus 2 minus 4 would be minus 8. Not a lot in there to simplify, but you can combine the plus 4x with the plus 2x, and you would get that this is equal to negative x squared plus 6x plus the xy term minus 4y minus 8. All right. That is not a multiplication sign. That's my really poor excuse of a subtraction. So we will white this out and fix that. So distributive property, there has got to be a more efficient way than writing out this second line, and there in fact is. We're going to look at that today. We would take these two answers and we would say that they are in units squared because we're drawing over here in square units as well. If we go and check, did we get the right answer? Negative x times x would be negative x squared. Negative x times negative 4 would be 4x. Y times x, there's your yx tile. Y times minus 4 would be minus 4y. 2 times x, there's the other 2x to go with our 4x. And 2 times minus 4 is minus 8. So we did get the same answer as the diagram, which is wonderful. Shows that our distributive property works. Each expression below represents the area of a rectangle written as a product. So you were given the product and we are looking for the sum. So instead of doing x plus 3 times 2x and x plus 3 times 1, we're actually going to multiply each term in the first set of parentheses by each term in the second set of parentheses. For example, I can multiply the x times 2x and the x times 1. Start there. X times 2x would be 2x squared. And x times 1 would be plus x. Then I'm going to multiply the second term, the plus 3 times 2x, and the plus 3 times 1. So I would have plus 3 times 2x is 6x, and then plus 3 times plus 1 is plus 3. So you can see I have the result of the first pair of multiplications, the result of the second pair of multiplications, and then I want to see if there's anything that's like terms that I can combine. And I can combine the plus x with the plus 6x for 2x squared plus 7x plus 3. And I did not have to draw anything. So, and that is my 4 outcomes that I would have had I drawn it. Had I drawn it, I could have done the 2x squared tiles, which I have 2x squared. It would have taken me 7x tiles. And it would have taken me 3 unit tiles. The bottom would have been 2x plus 1. Up the side would have been the x plus 3. I would have had the same dimensions, 2x plus 1 by x plus 3, and I would have had the same tiles inside. Instead, I was able to go through and use the distributive property to do that. Now, you will often hear your parents, if they ever did this in high school, they might call this the FOIL method. First, outside, inside, last. So you multiply the first pair of terms, the outside, the x and the plus 1, the inside, the 3 and the 2x, and then the last, the 3 and the 1. And that's actually the same order that I did them in. I definitely learned FOIL when I was a kid, and you can follow that. The other thing is just to know that every term in the first binomial needs to get multiplied by every term in the second binomial. That gives you all 4 of the parts you need. Now, this is not a binomial times a binomial. You're just distributing the 2x. So 2x times x is 2x squared. The 2x times 5 is plus 10x, and you are done. Much faster than drawing the algebra tiles. Next one as well, distribute the x. 2x times x is 2x squared, and the x times the minus y would be minus xy. Don't forget, if it was subtraction, it stays subtraction because there was no extra negative coming from this term in the front. Now, this one is a binomial times a trinomial, which means that you're going to have to do more multiplication. But if you have 2 things getting multiplied by a set of 3 things, you should have a set of 6 outcomes. If you look up here at the diagram, when you had a binomial multiplied by a trinomial, you ended up with 6 little rectangles. Same idea. So the 2x needs to get multiplied by each piece inside the second set of parentheses. So 2x times x is 2x squared. 2x times y is 2xy. 2x times 2 is plus 4x. Everything was addition, so I didn't really have to worry about that. Then you have to multiply the plus 5 times x, the plus 5 times y, and the plus 5 times 2. So plus 5x plus 5y plus 10. So I did end up with 6 terms, which is a good sort of checks and balances for myself. I have 2x squared. There's no other x squareds. I have plus 2xy. There were no other xy terms. I did have 4x and 5x, which I can combine for 9x. And then 5y and 10. And that's as simple as that one can go. Often when you're multiplying a binomial by a trinomial, it's still pretty big. Now, I have to tell you, letter E is the one that everybody gets wrong at some point because they don't pay attention to the logic. This one says 2x minus 1, and everything in the parentheses is going to get squared. That means everything in the parentheses is getting multiplied by everything in the parentheses again. So this question is 2x minus 1 times 2x minus 1. And if you don't bother to write it out, you will forget some of the terms. So 2x times 2x and 2x times the minus 1. So I'm going to have 4x squared minus 2x. And then I'm going to do my second one, plus 1 times 2x. Minus 1 times 2x and minus 1 times minus 1. So minus another 2x. And minus 1 times minus 1 would be plus 1. And so then I would have the 2 in the middle are going to get combined for 5x squared minus 4x plus 1. Please do not try to do this without writing it out so that you get all of the terms. 2x times 4x, that is literally a term times another term. It is 8x squared. There is no distributing. Distributive property is only over addition or subtraction. Since this doesn't have any addition or subtraction, it is not the distributive property. G, I'm only distributing the 2. 2 times 3x and 2 times the minus 5 would be 6x minus 10. Plain and simple. That was fast. And the same with H. You're multiplying the one term that is outside by everything on the inside. 2xy plus y squared, y times y, plus 3y. And that's all there is on the front. Some of them harder than others, depending on whether it's only one set of parentheses or 2 sets of parentheses. Examine the equations you wrote for parts B, C, G, and H. This pattern is the simplest form of what mathematicians call the distributive property. Multiply the following expressions without an area model to write them as sums instead of products. So guys, we've been doing this for over a year. Distributive property is not something new. The only thing that's new is maybe that there's extra variables or maybe there's some extra negatives. So this part is very straightforward. I know that people often think it is very silly that I continue to write these little rainbow arrows, but I tell you right now, it keeps me from forgetting the second multiplication. So 2x times 6x, 12x squared, and 2x times 5 plus 10x. 6 times the 4x and 6 times the minus 1. Not too difficult. Don't forget about what happens when you multiply variables. X squared times 4x is 4x. This is x times another x, which makes it x to the third, minus 2. I have an x squared and a y. Cannot combine those, so I just put x squared y. Same idea on D. I cannot combine the y and the x because I don't know if they're worth the same. They're probably not. So 70xy plus, and 7y times 11y makes 77, and y times y is y squared. Last one, don't forget about what happens when you have a negative times a subtract. So negative 5x times 3x is negative 15x squared, and most people get that. But the negative 5x times the minus 8 is really like a negative times a negative, and it becomes positive 40x. It's also worth the same as minus a negative 40, but then you would change it to plus a positive, and the x would stay. Does order matter when multiplying polynomials? Investigate this question with your team. Well, I'm your team for now. Are x plus 1 times 7x plus 1 and 7x plus 1 times x plus 1 equivalent expressions? Justify your answer with an area model. Then write an explanation using at least one of the properties in the math notes box in this lesson. Guys, we are going back in this one to 7th grade. This is the commutative property. I am changing the order. One thing in parentheses times another thing in parentheses. If I change the order and just change which one I put in front and which one I put in the back, it's still going to give you the same product. It is multiplication. So when we go to multiply this, well, it says to use an area model, which is going to be very large. But let's say we've got 1, 2, 3, 4, 5, 6, 7 x's plus 1. So that is a length of 7x plus 1. And then we're also going to have a width of x plus 1. So I'm just going to have an extra here all the way down, x tiles along the top. That's what gives us the extra 1, and then a unit tile. So this is x plus 1, and this is the 7x plus 1. That gives us a total of 7x squared plus, and then I've got 1, 2, 3, 4, 5, 6, 7, and an extra over here, plus 8x plus 1. And basically what this one is saying would just be a rotation of this one. It's the exact same drawing, just 90 degrees turned on its side. You're still going to get 7x squared plus 8x plus 1. We know from the previous lessons that rotation preserves area. That's not going away. That all of a sudden you're like, whoa, we haven't talked about that in a few days. And also because multiplication is commutative. We remember the commutative property, and my writing is very small, but are they equivalent? Absolutely. We have everything backing us up on this one. Are x minus 1 times 7x plus 1 equal to 1 minus x times 7x plus 1? So we have to first of all notice this has a 7x plus 1 and this has a 7x plus 1. That hasn't changed. This one has x plus 1 and this one has 1 plus x. It is subtraction. And we actually don't need to do any work because we can actually just go back to our properties and say it's not going to work because the commutative property only works for addition and multiplication. Commutative is not a property for subtraction. We cannot assume that x minus 1 is going to be equal to 1 minus x. They are not worth the same because it is subtraction. Which expressions below have the same products? So we're looking for ones that are going to have the same value. I want to find ones that have the same two things inside the parentheses, and within the parentheses, they have to be the same order. So this has x minus 5 and this has 5 minus x. They're not. So I want to look for anything else with an x minus 5. This one also has an x minus 5. The first one has 2x plus 3. This one also has 2x plus 3. The first set of parentheses just flip-flopped with the second set. So I know those are commutative property. Those are going to be equivalent. Is there anything else that's got x minus 5 and a 2x plus 3? You actually have to be a little creative on this one. We've switched it to a negative 5 plus x, which is worth the same as x minus 5. We've also got 2x plus 3. So surprisingly, that one is worth the same. It'll have the same value because negative 5 and minus 5 are going to work the same. There is one other pair. There is another pair that has that same funky property to it. This one has 5 minus x, and this one has negative x plus 5. They both have an x with a negative in front of it, just this one is a subtraction negative, and they both have a 2x plus 3. So this one and this one will also have the same product. Now, the last one that's there is optional. It really is meant to be practice of the things that we've already done and a little bit of an extension. So you'll notice that on these last 4 problems, some of the information is on the inside and some of the information is on the outside, and we're looking for you to sort of put the puzzle pieces together. Anyone that enjoys Sudoku, this is your thing, okay? So I'm just going to do the first one as an example so you hear the process, but I'm going to leave the other 3. You can check the filled in notes to see if your answer's right, but I would challenge you. It's really good practice to try to see if you can figure out the missing pieces. If this side is x and the tile is worth xy, then we know this side has to be worth y. If this side is worth y and the rectangle on the right is worth 3y, then this dimension has to be 3. So it's a little bit of a, what do I have? What do I need? What do I want to get my way through the problem? I guess I'll do one other one. If this is x squared and this is 12x, the thing that they have in common is x, which means it must be this dimension that they have in common, making this an x. Well, if I know this is x, then the other side has to be 12, because 12 times x would give me 12x. If I know that this is x, then this must also be x for that to be x squared on the inside. Right. 5 on this side. I now have a 12 on this side, makes it 60. 5 on the bottom, x on the left, makes this top corner 5x. It does ask us to write the area as a product and a sum. So you would go back. This would be y times x plus 3. That's your product. xy plus 3y would be your sum. Product is where you do the length times width, and then the sum is where you tell me the names of the areas that are right on the tile themselves. This one is going to be x plus 5 along the bottom, x plus 12 up the side. That's your length times your width. And then if I total up what's inside, x squared plus 12x plus 5x, which is 17x plus 60. And then I dare you to give the other 2 a shot because they're a lot of fun for someone like me. And there's got to be some of you out there too who want to fill it in. And if not, I would be happy to do those last 2 in class. See you then.